Hey guys, here we are with another Algebra 2 video. We got section 7.7 or 7-7 today. We're learning about the number e and natural logs. Okay, the number e is a special number like pi. It goes on forever without repeating. It's like 2.71828 ... Okay, it'll go on forever without repeating and never ending, kind of like pi does. Alright, and is often used in exponential equations. You'll see stuff of the form like y equals e to the x. And we'll have some story problems involving finance that use e. Okay? Just like exponential equations, its inverse is a log. But because e is a special number, it's going to have its special log. And we're going to call it natural log, or ln. Alright? Natural log, we're going to abbreviate that ln. And that's probably Latin or something for naturalist logolus. Who knows? Okay, so ln of 4 is like log base e of 4. So if you see natural log, that's like log base e of 4. And if we have log base e of 4 that equals x, then we can flip this around. X is the power of e that would give me 4. Okay? So let's work on changing this. We're going to write the exponential equation in log form. So if we have e to the x, okay, one way we can do this is we can log both sides, natural log on both sides, okay? And then we can use our log properties to pull this exponent down in front. So now I have x times natural log of e equals natural log of 8. Well, e and natural log are inverses, so they would cancel out and be 1. X times 1 is just going to be x. And we'd have x equals natural log of 8, or natural log of 8 equals x. Okay? Why don't you give this one a shot? Go ahead and pause the video, and you can work on those two. Alright, let's welcome back. Let's see how you did here. Okay, we're going to natural log both sides. Okay, that's allowing us to bring that 5 down in front. Natural log and e would cancel out. We'll have 5 equals natural log of x. Over here on this one, very similar to our first one that we did, natural log, x comes down in front. Natural log and e would cancel out, and we'll get natural log of 4. X would equal natural log of 4. Got the hang of it? It's not too tough. It's the same stuff we've been doing with exponentials and natural logs, just now we're using two special ones. We're using e and its opposite, the natural log. Alright, we went from exponentials to logs. Now let's go the other way, logs to exponentials. Change each log equation into an exponential equation. We got two ways to look at it here. This is the old way. Let's look at this first. Okay? If I had natural log of x equals 2, okay, the old way we tried to flip these around. 2 equals natural log of x. And we could use our little saying to help us out. 2 is the power of e, because this is natural log or log base e. So 2 is the power of e that would give me x. So e to the second would equal x. Alright, because this is 2 equals log base e. That's what natural log means. So 2 is the power of e that gives me x. Okay? The second way, and this really works better with e and natural log. I don't think we can go backwards and use it with our old ones. Okay, this really works best with e and natural log. If I have this, natural log of x equals 2, I can raise each side up as a power of e. Okay, e to the natural log of x equals e to the second power. Right? And we can look at it like this. E and natural log cancel out, and the x falls down to the bottom, equals e squared. Okay, because e and natural log are inverses, they're opposites, they cancel out. And the only thing we had left over there is x. It's going to fall down to the bottom, equals e squared. Alright. I'll try to leave it there so you can see a little bit of both. Okay, whatever way you think is more comfortable for you, go ahead and give it a shot. Remember, this way is probably going to only work best with e and natural log, because it's already partnered up. Like e and natural log, those are the ones we're using today. Those would partner up and cancel out. Okay, not quite the same as if we would have like 5 to the x, and then we'd also have to have log base 5 that we're working with in order for that to work. Alright, let's see how you did. Okay, we're going to bump up e to the power of e. Natural log and e cancel out. X falls down. X equals e to the 8th power. Same idea over here. Bump up e to the power of e. E and natural log cancel out. 10 falls down. E to the x. Alright, not too bad. Not too bad. Okay, take a look at those. Compare that to what you had and see if you can see where you made any mistakes. Moving on. Okay, all the log properties from our previous sections will still hold true for natural log as well. So if I have natural log of x to the y power, I can bring that y down in front with the power property. If I have natural log of x times y, I can separate those out into two individual logs that are being added together. And if I have natural log of x divided by y, I can separate those out into two natural logs that are being subtracted. Okay? So and these can all go in reverse too. It doesn't have to be this going to this. We could have this going to here. Like in our first example here, I'll give you a second to write that down. 3 times natural log of 10 minus natural log of 8. Okay, I'm going to go with reverse of the power property. I'm going to bump this 3 back up top. Now I have natural log of 10 to the third minus natural log of 8. Okay, well, what's 10 to the third? 10 times 10 is 100, times 10 again, 1,000, or a 1 with 3 zeros. You remember your powers of 10 shortcut from algebra or pre-algebra. A 1 with 3 zeros. Minus natural log of 8. Okay, they're separated by a minus, so I'm going to put them together as a division problem. Natural log of 1,000 over 8. And 1,000 over 8 would reduce to 125. Natural log of 125. Okay, if it started out like this, separate, I think this is pretty as far as we can go, like putting it back together. Okay, the example in the book wants us to break this down and go back again. It's like, oh, natural log of 125. Well, 125 is 5 to the third. And then I'm going to bump that 3 down in front. See, now it feels like we're pulling it apart again, and I don't like that. Okay, I would have probably stopped right here for this problem, because this is all putting it back together. And then once we get here and start doing this step that I feel is like pulling it back apart. So yeah, I don't know. I don't like how the book did that one. I would have stopped here. Simplifying it, putting it back together, and then pulling it back apart. I think I would have stopped right here. But if you went here, that's great too. It's all equal. Down to this area would be great. Okay, take a look at that. Again, review here. We did the opposite of the power property. We bumped the 3 back up top. We did 10 to the third. It's 1,000. I had natural log and natural logs. I can put them both back together. It was a minus in the middle, so we're going to divide. And I did 1,000 divided by 8 and got 125. You could, if you saw it, go further with 125 being 5 to the third, and then bump that 3 down in front using our power property the other way. Alright, last page. 2 more examples to go for today. Okay, we can also solve equations and inequalities with this. Okay, in order to get these answers, we need to know where e and natural log are on our calculator. Okay, and because they're inverses, the calculator are super nice, and they put them right next to each other. ln right here, and then e is its opposite button here. So if I go second ln, that's how I get e, and then it bumps it up there as the exponent part. So that's where those buttons are. If I want to know what e to the fifth is, second e to the fifth. Okay, natural log. Well, you know what? Let's do that. Let's go natural log of our second answer, of our last answer. And boom, it goes right back to 5. They're inverses. Okay? So that's where those buttons are on the calculator. Alright, we're trying to solve for x. It's in the exponent of an e, so I'm already thinking natural log. But before we do that, we have to get the e part by itself. Okay, we can't just natural log everything. We want to get the e part by itself first. So we're going to add 5. Okay, next step, we're going to divide by the 4. Alright, and now I have that e part by itself. We're going to natural log both sides. Natural log and e will cancel out. The negative 2x will fall down to the bottom. And then we'll divide by negative 2. Natural log of 2, close your parenthesis, divided by negative 2. Okay, we should be coming up with negative 0.3466. Alright. Okay, one nice thing for the teachers with these natural log and e is that they rarely come out to be nice numbers. It makes you nervous, but it's good for us because then we're not always so worried about making sure a problem comes out nice. Okay, and you kind of have to get over your fear of decimals too. It's not always wrong, or you didn't make a mistake somewhere if you get a decimal answer. A lot of these are going to come out as decimals. Very rare if you're going to get a nice answer here with these. All right, let's give you a second there to try this one on your own. Okay, step 1. What do you think here? I'm going to use my power property and bump that baby down. Use my power property of logs there and bump that down in front. Okay, then I'm going to divide by that 3, get rid of it. Greater than 10/3. Now I have the natural log part by itself, so I'm going to raise each part up as a power of e. E and natural log cancel out. 3x plus 4 falls to the bottom. E to the 10/3 power. Then we're going to minus 4. And divide by 3. Okay. So we'll have e, second e, to the 10/3 power. Bump it back down. Minus 4. Now we got to do that whole top part. So really what I should have done here, let's go back. Second INS is going to be second insert, parentheses. Scoot back on over. Did you guys see that one? Second INS is how you get to insert. You can go back and it'll put something in there. Then you just have to bump over to get out of that insert mode. Okay, so e to the 10^3 minus 4 parentheses on the top. There's my top row, divided by 3 on the bottom. Okay, and we should be coming up with 8.0105. All right, now this one was 3x plus 4 to the third. So you kind of got to watch this. Same rules, can't have negatives here. Well, take that back. Yes, you can. So I guess we don't have to worry about it this time. Like with our other ones, we had to make sure it stayed positive. So we're just done right there. No second checking. Okay. X is greater than that. 8.0105. So we should have minimal time left here, guys. Looks like we had a 15-minute video, about 16 minutes, and it probably took you 5 to 10 to get through that. So think how long this